In this video, we're going to do a question about an inclined plane. A car of mass 1 ton goes at a constant speed down a slope inclined at theta degrees to the horizontal, where sine of theta degrees is 1/20. So to start the question, I know the following. I have an inclined plane, and I do know that that is theta degrees. Okay. We also know that sine of theta degrees is 1/20. Part A is asking the following. Determine the total resistance to the motion. This resistance is assumed to be constant. The first thing you need to notice is that is in the given question, we have the following key pieces of information. It's coming down at a constant speed, and we also have a mass of 1 ton. Now the constant speed gives me that forces resultant must be 0 because of the constant speed. So let's have a look at all the forces that are involved in this question. So when I have the inclined plane, let's just dot represent the car. Then I have the weight of the car pushing down vertically. So W. But this W consists of two pieces. The first piece is parallel to the plane, and another piece is perpendicular to the plane. Okay, so we'll break it down into two pieces. The first piece perpendicular to the plane, and that goes that direction. And then I have a piece that's parallel to the plane, that direction. Between them, it is still theta degrees there. Okay. Then I have the normal force. Now the normal force is acting perpendicular to the plane but upwards. Now this force here and this force here, the blue and the red, will cancel. They're in opposite directions. So it's actually only the blue that sits here, that's parallel to the plane, that's left over. But because the resultant is 0, that must be cancelled by a force of resistance that's against the motion. Now to go against the motion, resistance has to be parallel to the plane but up. So R the resistance. Okay. So let's look at this triangle. So it's this triangle that's the key to the question. There's a 90 degree, there's theta, and I know this is W, and this is the unknown I'm looking for. Let's just call it R. And that's a piece that's parallel to the plane, same magnitude, just in opposite directions. Now to work that out, you will go opposite over hypotenuse, which is sine. So you will go sine theta is opposite, which is R, hypotenuse is W. So R is equal to W sine theta. Now W, which is the weight, is mg, so m times g. And that you must multiply by sine theta, which was given to be 1/20. Now m, 1 ton, that's 1,000 kilograms. Remember, always in kilograms. G is on the formula sheet, 9.8. Then times by 1/20. And if you work that out, you get 490 newtons. Good, that's the answer to part A. Let's read part B. Assume the same resistance as in A, that's the 490 newtons. The car can ascend the slope, that means go up the slope, with a maximum acceleration of 1 meters per second square. Determine the driving force by the engine when the maximum acceleration is reached. So if you think about it, as you go up this hill, the force of the car, the engine must provide the force to pull you up. But resistance will push down the hill. Okay, so in this case, the resultant force is not 0. So first let's talk about the resultant force. So F resultant, which is MA. Now the mass is 1,000 kilograms, must always be in kilograms, and the acceleration is 1. So over 1,000 newtons as the resultant force. Now, which forces are acting in this situation? So as I have the plane, I'm just going to draw it here, the theta there. So from the plane, I now have the force of the car pushing up the hill, I have resistance pushing down the hill against the motion. Yes, I have the normal force pushing up, perpendicular to the plane, but that's irrelevant because that will be cancelled by the component of the weight that's perpendicular to the plane. So the piece that's left over is this piece here, parallel to the plane. That's also pushing down. Now remember, in part A, I've worked that out. That was the 490 newtons. So that was a piece parallel and the piece of resistance because they just work in opposite directions. So in this particular case, my force resistance must equal, now think about it, what must be bigger? The bigger one must be the force going up because it needs to win. So I start with the driving force. From the driving force, subtract the resistance that's keeping it back and subtract the weight, but the piece that's parallel to the plane. Could now rearrange this, work out for F. So when I rearrange it to make F the subject, it's Fr plus R plus the weight and the piece that's parallel to the plane. We've worked out Fr, that's 1000 newtons. The resistance from A is 490 newtons. And the piece that's parallel to the plane, that's a piece of the weight, that is still 490 newtons as well. Because in part A, it's the same as resistance, they just worked in opposite directions. So adding this all together gives me 1980 newtons. So that's a driving force that has to be exerted by the engine of the vehicle to get it up the hill with this acceleration of 1 meters per second squared. Thank you.